In the course of probability and statistics, till now we have concentrated on the topic probability, random variables and their distributions. We studied various kind of discrete and continuous distributions. We discussed joint distributions and we discussed sampling distributions which arise in the study of certain population and sample. So, now it brings us to the second aspect of this course, that is statistics. So, we firstly introduce what is the term statistics referring to and its historical development. In this particular section, we will tell the various types of statistics that are used and also the representation of the data through statistics. So, let me start with the term what is statistics. So, in plural sense, when statistics word is used, it refers to numerical data which arises in any sphere of human experience. So, in our day to day life, from the following examples, I will try to show that everywhere we are making use of statistics. For example, the records of birth and death are kept in every municipality or in village or in town office. So, this data represents birth and death statistics. Every state or a town or a police station keeps the record of crime statistics, that is the number of crimes committed under various categories during a given period. A certain market may keep record of the consumption of food products of various types. For example, what is the market for say South Indian dishes, what is the market for consumption of say Chinese dishes. So, the data on that comes under food products consumption. Government regularly keeps the record of agricultural production of different crops. So, how much production will be there under say wheat, how much production will be there for rice, how much will be the production for the pulses, and this type of information is extremely important for making the policies by the government, how much should be released in the market, what should be the pricing, whether there should be any import of these products from the other countries to meet the shortfall, or if there is a surplus, then should the government be exporting, it should be encouraging the exports. So, the agricultural production data is one of the most important data that is kept by the government. Industrial production in various sectors, for example, how much capacity of the heavy industry sector is there and how much it is actually producing, and then how much it is contributing towards the growth of economy, in the sense that whether we are able to give enough things for our local consumption as well as for international exports. For example, metal industries, steel industries. Similarly, what is the production for the medium sectors or the small sector industries. Complete industrial production data is of extreme importance to the government for formulating its various economic policies, and also to tell that how much government should invest in various kind of industries, what kind of facilities it should give to those industries. So, from this point of view, the industrial production data or the statistics is very important, and it is regularly collected by the government. For example, another data which is regularly collected is earnings through export of various commodities. For example, the government gives certain incentive for export of export item of a particular type, and then it wants to see the effect on that, what is the increase in the export of those categories. For example, it gives certain relief to those manufacturers who are producing a certain technical item, then for example software, and then whether it leads to the increase in the export of that particular item. Now, these has some far-reaching consequences. For example, if you see that there is an increase in the export, that means there must have been a better opportunity for the employment in that sector, people must have earned more, and so on and so forth. So, this type of data is of importance. Statistics are kept in areas such as sports, where we keep record of the runs scored by players, wickets taken in a cricket match, in a football match, how many goals are in a hockey match, how many goals are scored, how many matches are won by different teams. In say athletics, what are the running times of the top athletes for certain events, say 100-meter race or 200-meter race, etc. In social studies, we may keep record of the age at marriages of the women, age at marriage of the men, on the average how many marriages persons are doing in a lifetime, what is the age of the parents at the birth of the child, what is the infant mortality rate. Various statistics of this kind are helpful for formulating various cultural policies and also social policies by the government for health and family welfare and for various other kind of things. In medical, we keep track of the statistics on the incidence of certain diseases. For example, what is the incidence of tuberculosis, what is the incidence of malaria. If it is more, then government will try to formulate a policy so that it can reduce the incidence, what steps should be taken, what are the pockets where it is more, so they can study the socio-economic profile of that and try to create certain reforms there so that the incidence of those diseases can be reduced. If there is a new epidemic, then how to control that. So, the data on the incidence of diseases is regularly monitored by the government agencies, by the medical council. What are the survival rates for certain diseases? So, whether if the survival rate is less, whether new drugs should be introduced so that the survival rate can be increased. What are the effects of the medicines? For example, if a medicine cures a disease, but it creates certain side effects so that the person dies of something else. So, we need to have a data on the effects of the medicines. Relation between certain habits and diseases. For example, is there a positive correlation between the habit of smoking and say lung cancer or TB? Therefore, those causes should not be encouraged, which give rise to certain diseases. For example, if a locality is unhygienic, then it may give rise to cholera disease, etc. So, the data on the sickness or the diseases or the deaths due to certain diseases is regularly supplied by the hospitals, by the medical agencies, and it helps government and other medical research organizations to formulate various kind of policies for curbing the incidence of those diseases or curing those diseases or controlling the diseases. The number of accidents due to various reasons such as road accidents, rail accidents, air accidents, ship accidents, and what is the mortality or fatality rate due to these accidents. For example, if it is observed that there are large number of accidents due to a particular aircraft, then the aircraft may be grounded and that particular company will be asked to rectify that kind of those kind of defects so that such accidents are avoided. For example, if accidents are occurring due to collision of trains, then certain devices should be installed which will lead to detecting that there is another train on the same rail line nearby, and therefore the driver should be alerted. What steps can be taken to reduce the number of road accidents? So, this information on actual accidents and also the fatality rates due to these is collected to make policies regarding these things. Another kind of information which is extremely useful to the companies which produce automobiles. So, for example, already how many automobiles are available in the country, then what is the length of the roads, how many people are in the age group which can hold valid license for driving those vehicles. So, this type of information is available, is useful for the automobile companies to make an estimate that how much production they should do for these things. Another kind of data that is kept is the number of voters in different constituencies for parliamentary elections or assembly elections, and the description of those types of voters. For example, how many males are there, how many females are there, how many are between age group from 18 to 25, how many are between say 25 to 35, so that the leaders or political parties can make plans accordingly that those should be giving benefits to the voters of that type which are there in their constituencies. The collection of the statistics or the utilization of the statistics is not only done in the government sector or social sector, it is extremely useful in the sciences or engineering or technological studies also. For example, physics, chemistry, biotechnology, in each of the or say economics, everywhere the use of statistics is there. For example, physicists will be interested in knowing the movement of the planets, the number of planets, what are there in the solar system, what is the number of the stars in a particular galaxy, what is the number of galaxies, comets, astronomical events such as a movement of a certain comet or hitting it into another planet, etc. Events such as solar or lunar eclipse, position of certain stars and planets, etc. The data on all these things are extremely useful to the cosmologists. Physicists also use the data in other disciplines such as movement, the number of say electrons or number of neutrons or various protons, and also they are using in various metallurgical studies, the composition. The people in chemistry or chemical sciences, they study various kind of chemicals and their compositions. The biologists, they study genetic makeup of certain human beings, the genetic makeup of certain item. There are biometric studies. In industry, when a manufacturing is being done, then what is the percentage of the defective items produced by that particular manufacturing process. It helps us to rectify or improve the manufacturing process so that the number of defectives can be reduced. In economics, the consumers of certain products, what is their capacity to spend, what are their income levels, what are their professions. So, these things are useful for creating products needed for certain particular type of consumers. So, for example, if a new soap is to be sold, then they find out that what should be the price of the soap, so that it is affordable to most of the people in that particular income group. If there are people with high income in a particular place, then they can introduce a soap which is of high valued, and therefore they will like to make it more fashionable or more attractive, so that those group of people are attracted to that. So, we can see that almost every area of human activity involves collection of statistics, and it is actually done, it is used by agencies, by individuals, by organizations, by people which are relevant to those statistics. And we can actually say that the term statistics or the usage of statistics is as old as the civilization itself. In fact, ancient texts show that, for example, in a town or in a capital of a certain state, how many inhabitants are there, how many houses were there, or what is the size of the army, how many infantry people are there, how many horses or elephants were there in a particular army or in the army of the enemy. this type of data we read in the ancient texts, either Indian or European or American texts. Such data was available, it is recorded. Therefore, the term statistical information or the data has been in use from ancient ages. And it also shows that people were familiar with the statistical methods for planning the affairs of the war, state, etc. Records of census data from Europe, America, etc. are available from middle of 15th century onwards. There is data from England or from Scotland on certain professions, that these many people work in this profession, etc. This kind of breakup, detailed breakup of the data is available from European countries or even from USA from 15th, 16th and 17th century, etc. That means the people have been aware of the importance of the data as well as statistical methods to how to use that data, how to interpret that data from quite long time. It is not a new subject. However, the term statistics, as we use it for the subject statistics as in a singular, it was coined by the German scholar Gottfried Aschenwald around the middle of 18th century, and first time it was used in Britain by John Sinclair, who wrote a series of volumes from 1791 to 1799, which gave the communication between the ministers from Scotland on various aspects of the data. In the year 1797, the term statistics was used in the Encyclopedia Britannica. Now, related to the statistical methodology, so now you can understand that there are two types of meanings of the word statistics. One is the data. Statistics means the data, the numerical values of the observations which are taken on various aspects of human activity, as we have given examples of almost every area of human activity. The second is the term statistics, which is referring to the subject of statistics, and this means the statistical methods which interpret a certain data, which analyze certain data and give inferences on based on that data. That is called the subject statistics. So, now we will refer it to by saying statistical methods or statistical techniques or statistical inference. The modern statistical methodology, the earliest references are to the normal distribution. Most probably D. Moiver in 1733 he wrote a paper which appeared in an obscure journal, and therefore it was not known. It was later discovered in 1924 by British statistician Carl Pearson. In this one, most probably for the first time he gave what is known as normal distribution, and he gave it as a arising in a large number of Balmeranian trials. He obtained it as a limit of certain sums of random variables. It is known as one of the first central limit theorems. The great French mathematician Laplace, in his manuscript in 1783, he said that normal curve can be used for describing the probability distribution of errors. So, when we are doing certain measurements and those measurements are not accurate because of the measuring instrument or by the person who is measuring that, so there may be errors, and you take several observations on that. So, when you take several observations on that, you have several values corresponding to those errors. So, if we plot the frequency curve of that, it looks like a normal distribution curve, and this theory was propounded by French mathematician Laplace. Later on, the great mathematician Carl Friedrich Gauss, he considered the study of planetary motions, that is the theory of motions of heavenly bodies, and he also came up with the same conclusion that the distribution of the errors for those astronomical measurements can be nicely described by the normal distribution. So, his treatise came in 1809, but he credited Laplace by telling that this idea was from Laplace, but in fact the normal distribution has a name Gaussian distribution because of the Gaussian study or the study by Gauss on this topic. However, the most appropriate usage of statistical methodology was probably done first by Belgian mathematician Quetelet, who lived from 1796 to 1874. So, he studied, apart from this planetary motions etc., he studied the usual statistics such as heights of a large number of people. So, he said that if we represent this distribution of heights using a bar diagram, then the picture resembles that of a normal distribution. He prepared a list of various topics, more than 40 topics, and he submitted it to British Statistical Association, and he said that all these topics can be studied using statistical methods. So, as early as earlier 19th century, people were aware that there are various phenomena where statistical methods can be used. That means the phenomena are not deterministic. This idea was there much earlier. George Mendel, the Gregor Mendel, he experimented, he did various genetic experiments and mostly on peas etc., and he concluded that the laws of heredity are statistical in nature. Influenced by the Darwin's theory of evolution, lot of people started studying the laws of heredity, and one of the famous works on that is by Francis Galton, who happened to be a cousin of Darwin. He worked on the theory of evolution, and his treatise Hereditary Genius came in 1869 and Natural Inheritance in 1889. And he observed that many of these hereditary laws are actually statistical in nature, and therefore he introduced the concepts of correlation and regression in his studies. In particular, he studied the heights of the children in comparison with the heights of their parents. One of his famous studies is that the children of taller parents are tall, but less taller than their fathers. And again, the children of shorter parents are short, but taller than their parents. So, he termed this as regression towards normality. That means you are converging towards from the height you are coming down little bit, and from lower side you are going little bit up. That means there is something called normal heights, and he called it regression towards normality. So, probably these are the first references to the terminology of correlation and regression which is used in modern statistics. From 1890 onwards, two centers of statistics got developed. One was in University College of London and another was the Rothamsted Experimental Station in England. So, in the University College of London, the mathematician or the biologist or the economist Carl Pearson, he started studying, or you can say introducing the concept of statistics in a very systematic way. He was doing studies in evolution, heredity and also various other aspects. In 1901, he started the famous journal called Biometrica, which is the one of the top journals for the study of statistics. He was the first one to talk about the chi-square test statistic. That means not only that you say that this data fits a particular distribution, say a given data, we say that it is fitting nicely by the normal distribution or by a gamma distribution, but how to do a statistical test for that. It is not just by observation, but by developing a proper procedure for that. So, he was the first one who introduced this chi-square test statistic, or you can say chi-square test for goodness of fit. Till this time, there was still not very clear-cut distinction between a population and a random sample. That means, we are talking about full population or a subset of the population. There was not much distinction, but it was the 1910 book by G.U. Yule who gave a clear-cut distinction between population and sample. Around the same time, R.A. Fisher also gave a clear-cut distinction between population and the samples. Thank you.